Hello, my name is Farshad Khairi, and for project 1 I chose Chameleon Office. I started modeling the surfaces in Rhino and then using the Launchbox to create this hexagon mesh. The approach that I've been using in this project is using these three triangles and then getting two different offsets, because while flexing the model the order of the points will change, but we need the smaller one for this solid difference. Then this solid difference is protruded to create a shape like this. We can also use other methods like kangaroo to get similar results. Uh, then we can have the array of these three modules all along the surface using this Sirius knot, which is basically working similar to a for loop. And we also have the hexagon mesh, and of course the glazing surface at the back should be divided. So I used project to project all these lines onto that surface. In order to fill out the gap between two adjacent surfaces, we can either use these knots to scale the surface at the beginning in a way that these knots would be aligned exactly at the edge of the surface, or we can use the other method. So in the other method there would be another hexagon in a slanted way, and we can see that the corners are extended in a way that they're joining each other. So for having these random modifications to the model, we can use this part of the grasshopper and use these lists to call the items that we don't want, like the one here. And we also have the cables connecting the perpendicular structures to each individual modules. There are two different categories to flex this model: the global parameters, which will basically control the values in all the surfaces, and the local ones, but they can be changed from global to local and vice versa at any stage. This is an example of changing the opening of the modules in one surface. This is defined as a local parameter in this case, and it's just changing the parameter, this parameter, in one surface. As this is one of the main this was one of the main ideas of the actual design. The window to wall ratio, which is actually the ratio of these openings to the total area of the surface, is used as the analysis part. And we can see that the window wall ratio in this case is 34%, This is a brief representation of the Baked form here. This is the hexagon mesh, the perpendicular structures, the mesh on the glazing surfaces, and the cable, the modules and the cables. And this is one of the screenshots that can show one face of the module. Thank you.